Solving systems by elimination. We pick a variable to choose, and then we get rid of it. You guys have done lots of these before. I'm just going to go over all the steps. I probably won't talk too much doing these, actually, just because it's so common. I'm going to get rid of the x first. Why not? When I multiply this guy by 2, I get negative. Okay, so we're going to just multiply the top line by 2, because you can see here that those will cancel out, so we get negative 16y equals 30, and that's 15, sorry, negative 15, so y equals negative 2. So I'm going to plug in I only got half the problem right, so let's go to 10x plus 3 times negative 2 equals negative 6. That's going to equal 10x plus negative 6 equals negative 6. That's going to equal a 10x once I add positive 6 to both sides. It'll be 0. And don't worry though. Just remember that if you divide by 10, x can be 0. That's no problem. My final answer is 0, negative 2. Okay. Number 40. Number 40. I'm going to turn that 2 into a positive 6. So why don't I actually multiply this guy by a negative 3, and that will give me a positive 6, positive 21, and then a negative 3. Negative 6 plus 3, y equals negative 21. Those guys cancel out. That's 24. Y equals negative 24, so y equals negative 1. All right, plug it in. So negative x, I just chose the second one. Negative 1 equals that. Do this, bada bing, multiply 3 times negative 1, add 3, I get a negative 18, negative 6x, x equals positive 3, so my final answer is positive 3, negative 1. So do be careful. Just because you solve these guys out of order doesn't mean that you have to remember what your x coordinate goes here, your y coordinate goes second. This one's a little easier. I'm actually going to go ahead and just manipulate this. I'm going to go multiply the top one by 4, so that's going to be 4x. That's going to be 40, and then 16 times 4 is actually 64. Okay, so I was able to just manipulate it right there in the equation. That gives me 20y, and then I've got negative 40, no, positive 40, so y equals 2. Alright, so now what I'm going to do is I'm going to go back to the original unmanipulated equation and plug in a 2. Okay, and so if that's x plus 20 equals 16, that means that x has to be negative 4. So negative 4 and 2. If you do get fractions, you know something's wrong. Alright, that's elimination. Substitution is a little different because y has been solved for, or x. Okay, in all three cases actually, just the computer generated these as just y's being isolated. Now he's just a number, so that's kind of nice. We actually already have 50% of our answer. So now we just need the x coordinate. So I don't know why I put parentheses there, but we're going to go ahead and multiply that by 3. Negative 3x minus 24 equals negative 3. Negative 3x, we're going to move that negative 24. He's going to become positive over on the other side for a positive 21. So x equals negative 7. So it looks like that is my final answer. Alright, this is great because y equals 4x, so this means I can just substitute that y right there. So 8x minus 2 times 4x equals 0. So that 8x minus 8x equals 0, that's 0 equals 0. That's true. That means that's all real numbers. Okay. If this would have been any other number but 0, if it would have been absolutely any other number but 0, then it would have been no solution. Okay, so keep that in mind. Alright, I'm going to draw a little bar here to separate these guys. I see y equals 5x minus 11, so negative 7x plus 3 times 5x minus 11 equals negative 17. Okay, let me just make some space here. Alright, so I distribute the 3. Negative 7x plus 15x minus 33 equals negative 17. These guys get added together. Okay, I'm just going to do this carefully. Add 33. 8x equals, let's see what we got here. 16. X equals 2. Plug in a 2 for x, and I'm going to get a negative 1. So your final answer is x is 2 and y is negative 1. Okay. Alright, now this is the third way to solve a system by graphing, but if you can do the systems of linear inequalities, these guys are less work. So I only put a couple of these guys just because it's just a bridge to get to the linear inequalities. Hey, why is my hair bubbling right there? Let me go down. Okay, a little better. I like my hair up, but like not bubbly. Anyways, I digress. Let's do the first one first, then do the second. All right. Remember, we always go to the y-intercept first, so we go to positive 3. Y-intercept, not the x-intercept. Don't put a dot on the x-axis. Okay? Don't get confused. When we go to 3, it means we would go up 5 over to the right 2, okay, because that's my slope. But I can't. I'm going to have to go to the left now. And when I go to the left, I'm going to have to go down 5. 1, 2, 3, 4, 5 over 2. Now notice, though, that this is always read as a going left to right. So that is a positive slope. Don't have your eyes go towards the left. That's not a negative slope. We always read graphs going left to right. So this is increasing. Okay? All right, now that's the first line. Now line 2 starts at negative 1, and then it says up 1 over 2. Up 1 over 2. Always go to the right if you can. Go to the left if you have run out of room, but then you're going to have to change your direction. Okay? All right. All right. Looks like our solution is this guy right there, and that is negative 2, negative 2. So the answer is E. All right. X equals 1. Okay, this guy doesn't have a y-intercept because he's at x equals, so we're just going to draw a vertical line. Then this guy goes to positive 3, and then his slope is 1. He goes up 1 over 1. So I'm going to go ahead and draw that line. The solution to this system, okay, again, notice the equal signs. We intersect right there at 1, 4. So the answer is C. But when you go over here, it's different. This is where you got a shade because we have inequalities. Okay, and this is just means that you have windows of possibility, not just an exact value. Okay, my hair's bubbling again. Gotta get that down. Come on now. All right, so graph it like you normally would. Negative 2. Then we go up 4 over 3. Up 4 over 3. Okay, he's going to be a dotted line because I do not have a bar. All right, and then this guy is a positive 3. And then we're going to go down 1 over 3. And he does have a bar. All right, which means I can touch this line, but I cannot touch the dotted line. So if you were asked for, is this a solution, you want to make sure you got it. Okay, now first of all, I'm going to go back to the dotted line because I didn't do any shading. I'm going to go back to the dotted line, and these guys are, I'm going to go below because this is a less than. Okay, so I'm going to go below the dotted line. I'm just going to do a nice little shade there. Then this guy says I'm going to go above him because that is a greater than. So if you remember, we can draw a G there, so it's greater than. Greater than, this guy would mean we're above, we're on the stairs. Okay. Now what I want to say though, notice though that this guy is decreasing. So when I say greater than, he is actually on the top of it. This guy's less than, he's below, but you know, he is you know, you have to kind of keep in mind like the slope of your lines here, okay, to make sure you remember what is what goes above, what goes below. Always look at it as a staircase. You can see here that the intersection is going to be this area right here. Okay, so make sure that you darken that so I know clearly. We'll stop right there actually. and finish up in the next one.